Hi, welcome to another edition of Fun with Physics, the projectile edition. In this video, you'll be solving problems on a worksheet. This worksheet's due at the end of class, so put your first and last names up here, first and last name, not letter, first and last name. The only problems you'll be responsible for are circle 1 and 2, and you must show your work on these problems and put units on all answers. Problems 1 and 2, flip the paper over. Problems 6, 7, and 10. 6, 7, 10, and 1 and 2. So let me do problem 3 to start. Whenever you do a problem, identify what you have. Actually, I'd like to do problem 4. It says a pistol is held horizontally at a height above the ground. It says above the ground, and it says at a height, so this must be my dy. It's fired with a velocity. Well, that has to be, since the pistol's held horizontally, this has to be my Vx. And I want to know how far away, my delta x. Oh, let me put dx, sorry, dx. Try not to get out of that habit. So, you have 3 formulas, and in this space here, you can write the formulas. Vx equals delta x divided by time in the air. That's one way to do it, if you know your delta x. So, let me draw a little picture of a cliff and a projectile. This would be delta x. Your time in the air only counts over here when you're actually in the air. You have a velocity in the x direction, and you have a delta y. I want that drawn on there for you to get credit for this worksheet. This worksheet will be worth 6 points, so it's a sizable homework assignment. Next, after you've drawn that, and I assume you've drawn it by now, you have 2 other formulas. Time in the air is obviously the square root of dy over 5. You've got to remember the square root. And then delta x is also Vx times time in the air. Basically, it's a version of this problem. So you have 3 equations, and these 2 are basically the same equation. In this problem, I want to find dx. To find dx, I need my Vx and time in the air. So let's find my time in the air first. And when you do this, I want to see this written out on your paper. I don't want just an answer. I want to see that you put 1.5 divided by 5. And then I want to see an answer on each problem like this with the units on it. At that point, I'll do that for you. So I'll take my calculator, I'll hit second square root, and I have my parentheses, and I'll put 1.5 divided by 5. And if you do that, you'll get the correct answer. And I'll hit equals. And now I want to round it. That 7 will be rounded by this 7 to 8 to 0.548 seconds. That is an acceptable. This is your work. And these are the units with the answer. Next, I want to get dx. To get dx, I must take Vx, which is 300 meters per second, times my 0.548 seconds. And notice I'm showing work. And now I know dx will be something in meters. And I calculated this. Now I'm just going to round it to 164.32. If you have something close to that, it's just you rounded funny. 164.32 meters. So you have three formulas you're using in these problems. It's worth 6 points. For example, if I look at some of the other problems, in this one, from the top, clearly this must be your dy. This says velocity. That must be your Vx. If I go up to one of the problems you have to do, this says high, so that must be your dy. This says horizontal velocity, so that must be your Vx. Therefore, the only thing you could be looking for, well, you could be looking for two things. It says predicted time, so they want time and horizontal distance. So they want time and delta x, time in the air. They want both for this problem. So if you go through carefully and identify what you have, you'll be able to find the things you need with just these three formulas. Again, this one says high. This sends 35 meters away. If this is my delta y, then this has to be my delta x. For problem 2, I would carefully look at this formula to do problem 2. Well, there you have it. This worksheet's due. And then when you're done, please get on homework checks. Many of you have homework checks to do for projectile motion.